Rahim. Assalamu alaikum. In this video, I will solve question number 1 from exercise 12.1 from unit number 12, that is angle in a segment of a circle. This question number 1 is basically related with theorem number 1 and theorem number 4 of this chapter. Let's read out the question. Prove that in a given cyclic quadrilateral, sum of the opposite angles is 2 right angles and conversely. So first we need to know what is a cyclic quadrilateral. So a quadrilateral is a four-sided closed figure. Now let's see what is a cyclic quadrilateral. The quadrilateral whose vertices means whose corners lies on the circumference of a circle. So the shape that is enclosed in a circle and the vertices or the corners of that shape lies on the circumference, or you can say the boundary of a circle, then that quadrilateral is called the cyclic quadrilateral. It is also called inscribed quadrilateral, right? So if I roughly draw a circle, so if you see this is a closed four-sided figure. Its vertices lies on the corners, its vertices lies on the circumference of the circle, then this is called the cyclic quadrilateral. Now there is a property of cyclic quadrilateral that the sum of the opposite angles of the cyclic quadrilateral equals to 180 degree. Right? The opposite pair of angles are supplementary to each other. This means if you add up the two opposite angles, the angle sum must be equal to 180 degree. Let's move back to your question. So, prove that in a given cyclic quadrilateral, sum of the opposite angles is two right angles. Right angle means 90 degree angles, right? Two right angle means 2 into 90, that is 180 degree, right? So we just have to prove that the angle sum of the opposite angles must be equal to 180 degree, right? So we must have, since it is a cyclic quadrilateral enclosed, inscribed inside a circle, so we must need to draw a circle first. Okay, let's draw the circle. Okay, so here our circle is a circle with center O. Now we are going to draw the the quadrilateral. Let's say this is going to be like this, and from here the vertices of the quadrilateral must lie on the circumference, or you can say the boundary of the circle. And we are supposed to label the diagram. Let's say A, B, C, D is the quadrilateral in a circle with center O. Now let's write it down. What is the thing that is given to us and then what we have to prove. Given a circle with center O, a circle with center O, right? And ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Okay, now what we have to prove, the sum of opposite angles. Here the opposite angles will be B and D and A and C. So we have to prove measure angle B plus measure angle D, that is equal to two right angles. So if I say two right angles, this means 2 into 90 degree, and that is equal to 180 degree. And similarly, what we have to prove, that measure angle A plus measure angle C is also equals to 180 degree. Now we are going to do some construction. In construction, we'll be joining the points. Join O to A and C and label the angles. Label angles as angle 1 and angle 2. Now let's join the two lines. Join with the other color. So O to C and O to A, and we are going to label the angle as angle 1 and angle 2, right? Okay, now we'll be doing the writing down the proof with statements and reasons. Proof with statements and reasons. Okay, statements and reasons. Okay, so the very first thing we know from theorem number 1 from this chapter, that measure angle 1 is equal to 2 times of measure angle D. And what the theorem says, that the central angle is twice the circumangle, right? Or you can say the angle at the center is twice the angle at the circumference. What is the angle at the center? This, because of this arc ABC, this angle 1 is at the center. This is the central, and because of the same arc, this angle D is the circumangle, or you can say the angle at the circumference, right? And also angle 2, measure angle 2 is equal to 2 times of measure angle B, right? This is the central angle from this side because of ADC. Angle 2 is the central angle, and because of ADC arc, angle B is the circumangle. So for the same, for the 2 points, we are going to write down the same reasons, that by theorem, the angle at the center is twice the angle at the circumference, or you can say the central angle is twice the circumangle, right? So we are going to write it as angle 1, equation 1 and equation 2. From equation 1 we can take this 2 to the other side, and from equation 2 also we can take this 2 to the other side. Let's change up the colors. So from 1, if we write it down, that if we'll move 2 to the other side, it will become 1 by 2 of measure angle 1, and that is equal to measure angle D. And similarly from equation 2, if we take 2 to the other side, it will become half of measure angle 2, that is equal to measure angle D. It is B. Okay, we'll write down the reason as from 1 and 2. Now if we add the two equations, let's say we add the third and the fourth equation, what we will get, that is measure angle B plus measure angle D, that is equal to half. If we take common, it will become measure angle 1 plus measure angle 2. Now measure angle B plus measure angle D, that is equal to half. Now if we insert the value of measure angle 1 and measure angle 2, let's see what it is. Measure angle 1, here it is this one, and measure angle 2, it is this one. It is a complete central angle, and the complete central angle is of degree 360 degree, right? The complete circular angle. So instead of measure angle 1 and 2, we can write down as 360 degree. And 360 divided by 2 is 180 degree. So measure angle B plus measure angle D, that is equal to 180 degree. And we can write down the reason as it is the total central angle, you can say total central angle. This is the reason, right? So this was we needed to prove that, and similarly we can prove the other side as well, that is measure angle A plus measure angle C, it is also equal to 180 degree. And since by the statement 180 is equal to 2 times of right angle, right? So write 2 times of right angle and 180 degree is the same thing. Now conversely, what we have to prove, that if the opposite angles are of two right angles, or you can say if the opposite angle, sum of the opposite angle is equal to 180 degree, then the angle then the quadrilateral is cyclic quadrilateral. So we have already discussed the definition of the cyclic quadrilateral and its property, that the opposite sum of the opposite angles of a quadrilateral is equal to 180 degree. So we just have to write down now one statement only here, that conversely, if I write it for you people, conversely, that is measure angle B plus measure angle D, it is equal to 180 degree, right? This implies that the quadrilateral is a cyclic quadrilateral. And why? Because this is the property of the cyclic quadrilateral, right? Because this is the thing, now it is given, right? सो कन्वर्सली में क्या होता है कि जो चीज़ पहले गिवन थी वो बाद में प्रूव करनी होती है, राइट? नाउ दिस इज द थिंग विच इज़ गिवन एंड देन वी हैव टू प्रूव दैट द quadrilateral it is cyclic quadrilateral. This implies that quadrilateral is cyclic, right? This is because the property of a cyclic quadrilateral कि वो आपके पास क्या होता है, प्रॉपर्टी ऑफ साइक्लिक क्वाड्रिलेटरल के ऑपोजिट एंगल्स का जो सम होता है वो 180 डिग्री के इक्वल होता है, एंड दिस इज द थिंग ऑलरेडी गिवन टू अस, quadrilateral, right? So I hope you understand this sum. Thank you so very much. Allah Hafiz.